So we'll see Kruskal's algorithms today. Kruskal's algorithm, as we have already discussed in the previous video, we have seen greedy method, and when we were explaining greedy method, we discussed about the basic preliminaries about graphs and trees, where we discussed about minimum cost spanning tree. And Kruskal's algorithm is one algorithm which will help us to find out the minimum cost spanning tree for a given weighted graph. So here, Kruskal's algorithm, as you can see, the set of edges will be given. I mean, it'll be inputting to. We will input the set of edges to the algorithm, and initially the solution set will be empty. We have discussed this in greedy algorithm, where the basic steps we had discussed, where the solution set will be initially empty, and we'll take each input one after another. We'll check for the condition. If the condition is satisfying, we will put the item into the solution set. Otherwise, we will reject the item. So Kruskal algorithm also begins with the set of all edges, which is initially empty, and as the algorithm progresses, we will add on edges uh, to t for every instance of the edge. So we will check whether the condition has been satisfied or not. If the condition is not satisfied, we will reject the edge. And since we are going to find out the minimum cost spanning tree, we are sticking on to the edges, not vertices. So we have a graph given initially. We will be given with a graph, and that graph will be having set of vertices and set of edges. So since we are going to find out the minimum cost spanning tree, definitely all vertices will be there, but we are worried about the edges. So we have to select only those edges which are of minimum weight. So that is why we are adding edges. Okay, so we will be dealing with edges here. So the partial graph formed by the nodes of G and the edges in T consist of several connected components. So we definitely, when we see the example, it will be more clear. The steps, I'll come back to the steps once the example is done. And at the end of the algorithm, only the connected component remains, so that the T is the minimum cost spanning tree of all nodes of G. So we will come back. Last two steps, I think it may be little confusing the sentences if for understanding, but I'll come back once the example is done. Okay, so we are going to solve this particular problem. This is the example graph which we are going to take, and these are the steps that we are going to execute. What is the first step? It is to sort all the edges from low weight to high. So this is what Kruskal algorithm's steps. Okay, so you should not confuse between the greedy method, Kruskal algorithm, Prim's algorithm, and all those. Kruskal method is one specific algorithm for finding minimum cost spanning tree. Greedy method is an algorithm designing technique. Okay, where we can design any algorithm using greedy method. So here, Kruskal algorithm is nothing but we are inputting a weighted graph and we are finding out the minimum cost spanning tree. So what will be the first step? We have to sort. That is the first step. Sort all edges from low to high. Okay, so that is the first step. And second step is to take the edge with lowest weight and add it to the spanning tree. If adding the edge creates a cycle, then reject the edge. Okay, so just three steps. First step is to sort all the edges. Second step is take the first edge, that is the edge with the minimum cost. Take that edge, check by adding that whether any cycle is getting formed in the solution. So we are adding it to the solution, right? So by adding it, if suppose it is creating a cycle, then you have to avoid it. You should not add it, you should reject it. Okay, so that is the only condition you have to check. Third one is to keep adding edges until we reach all vertices. So we have to cover all this. So spanning tree definitely will have all the vertices and some edges where all vertices are getting connected, and we have the edges that is considered for which gives you the minimum cost. So the only three steps. So we'll see one by one steps, one after another. The first step is to sort the edges in the increasing order of their cost. So I just wanted to recollect the graph. So here you have uh, six vertices: one, two, three, four, five, and six. and almost all vertices are connected. You can see all the edges also. So what I'm going to do is, so based on this weight, I'm going to rearrange the edges in the increasing order. So edge 1 to 2 is the first edge, which is having the very less cost, that is 5. 1 to 3 is having 10. 2 to 6 is having vertex. 2 to 6 is having 20. 3 to 6 25. So like that I have rearranged the edges. So now what I have to do, next step is to create a table where you are going to add on each edge one after another from this table. So I have already made the table ready. So from this table I have to add each one edge after another to the table. Only thing is, after adding the edge, whether a cycle is getting formed or not, that we have to check. Okay, so this is the kind of table that I'm going to prepare. So initially, my edges considered will be empty because I don't have uh, anything considered as of now. And these are the components which are vertices for us. And initially, there is no graph also generated. So initially, everything is initialized and perfect. And what is the first step? First step is to add the first edge. So what is the first step edge in the table? That is edge from 1 to 2, where you have cost as 5. So you add the first edge. 1 to 2 you are adding to the edges, and vertices you just see connected components. I'm just one single array I'm just trying to form, where I have all the connected components together. So I'm just keeping 1 and 2 combined because it is already added. Okay, so the others will be separate only. We will accept it because there is no cycle. So we have the edge here. This is the graph getting generated after your first step. So what is the second step? Second step, you have second edge where you have weight as 10 and edge is from 1 to 3. So just check what is going to happen when we are adding 1 to 3 to your solution. What is going to happen? 1 to 2 you have an edge, and 1 to 3 also you have an edge. So this, there is no cycle. So you have an edge from 1 to 2 and you have an edge from 1 to 3. Fine, normal. So it is also accepted, there is no cycle. So add 3 also getting added to this. Now only rest left vertices are 4, 5 and 6. 1, 2 and 3 we have already considered. Now what happens in the next step? Third step, I'll just go back to the table. The third edge available is 2 to 6, which is having weight 20. Now 2 to 6, there is an edge. If I draw an edge from 2 to 6, nothing is going to happen, no cycle. So we can easily add it. So 6 is also added, accepted, and left is 4 to 5. Now what is the next edge? It is 3 to 6. Just watch what is happening. When we are adding 3 to 6, an edge from 3 to 6, did we get a cycle? Yes, we get a cycle. So here, whether we have to consider it or not, we don't have to consider it because it is forming a cycle. So we are rejecting it. 3 to 6 edge we are rejecting. We are not adding anything to the list of vertices. So here next edge is 4 to 5, which is giving 35 as weight. We'll check what is happening. 4 to 5, when that particular edge is added, what is happening? 1 to 3 6 is already added. 4 to 5, both 4 and 5 is not at present in the current graph which we have created. So this will stand as a separate thing. So we are creating just a small edge from 4 to 5. Both vertices are considered. We have an edge between 4 to 5. That's it. Okay, now what is the next step? Next edge we have to check. After 4 to 5, I have 2 to 4, which is giving 45. So now here 2 to 4, if I'm drawing an edge from 2 to 4, everything got connected. See, 1 to 2, 1 is there, 2 is there, 3 is there, 6 is there, 4 and 5 also there. So here I have all vertices now connected, and there is no cycle also. So there is no harm in selecting 2 to 4. So this has been selected, and now we will check the rest. Okay, so for the rest of the things, we have 2 to 4 we have already added. Now the left the next upcoming edge is 5 to 6. But if we add it, what will happen? 5 to 6, this is edge 5 and this is edge 6. So if I have a line like this, there will be a cycle getting formed. So I have to reject it. So reject it. Now what happens in the next one? 4 to 6. 4 to 6 also same thing is going to happen. Which is your edge 4? This is edge 4. 4 to 5, if you are drawing an edge, becomes a cycle. So you have to reject it. Now last one is 2 to 5. The last edge is 2 to 5. So I have my edge 2 here and 5 is here. So if I draw an edge between these two, again this is going to form a cycle. So that is also rejected. So 5 to 6 rejected, 4 to 6 rejected, 2 to 5 also rejected. So now what is my my minimal spanning tree? This is my minimal spanning tree, and this is how the Kruskal algorithm is going to work. So this is the algorithm where you are passing the solution set T and the set of all edges E and the total number of vertices, and this is how we are going to execute it. Thank you for watching. Hope it was useful for you.